In this session, we'll be starting the fourth module, network functions. Network functions are functions which give relation between the current and voltage at different parts of a network. They are classified as driving point functions and transfer functions. These functions are associated with the terminals or ports. Any network can be represented by a rectangular box. That is, a network means a group of elements, that is resistor, capacitor, voltage source, etc. We have studied many types of networks. That is, a network can be represented. Such a network can be represented by a rectangular box. Any network should have terminals. That is, terminals are needed to connect to other networks and also to take measurements. Two such associated terminals can be called a terminal pair or a port. This is a terminal pair or one port. If there is only one pair of terminals, it is called a one-port network. This is a one-port network. If there are two pairs of terminals, this is one pair of terminal, this is another pair of terminal. If there are two pairs of terminals, it can be called a two-port network. Input port and output port. Input port is the port to which energy source is connected, and output port is the port to which the load is connected, that is from where we take the output. In one port network, only one pair of terminals are there, that is 1, 1 dash. And in two-port network, there are two pairs of terminals, that is 1, 1 dash and 2, 2 dash. Voltage and current are assigned to each port. Here we have, in one port network, we have V as the voltage and I as the current. In the two-port network, we have, in port 1 we have V1, I1, and in port 2 we have V2, I2. So now we have seen what a one-port network is and a two-port network is. So now we will move on to the functions, driving point function and transfer function. So first let us see driving point functions. For driving point functions, the excitation and response are measured at the same point. It can be specified for one-port network and two-port networks. For one-port network, we can write Z of S is equal to V of S by I of S, and this is called driving point impedance function. The second one is driving point admittance function. Admittance Y of S is equal to I of S by V of S. These are the two driving point functions for one-port network. Coming to two-port network, we can write driving point impedance function as, there are two ports. For the first port, we can write Z1 of S is equal to V1 of S by I1 of S. And for the second port, we can write the driving point impedance function as Z22 of S is equal to V2 of S by I2 of S. And next, driving point admittance function. Driving point admittance function for a two-port network, that is Y11 of S is equal to I1 of S by V1 of S, and Y22 of S is equal to I2 of S by V2 of S. These are the driving point functions. That is, the excitation and response are measured from the same port. See, first port 1, that is V1 by I1. Second port V2 by I2. The excitation and response are of the same port. Here there is only one port, therefore Is by Vs and Z of S is equal to Vs by Is. Okay, now we shall see what is transfer function. Transfer function is a function used to describe network which have at least two ports, and it relates voltage or current at one port to voltage or current at the other ports. There are 4 types of transfer functions, that is voltage transfer function, current transfer function, transfer impedance function, and transfer admittance function. The function is used to describe network which have at least 2 ports. So voltage transfer function can be defined as G12 of S. Okay, G12 of S. Transfer function means output by input, that is response by excitation. The first one is input and the second subscript is the output, that is output by input. So we know that G means voltage transfer function means we have both voltage at the output and input. This is the output and this is the input, V2 of S by V1 of S. Okay, input, output. First one is the input, the second one is the output. Out we have G12 of S is equal to output, the voltage at the output by voltage at the input. Now we have G21 of S. This is the input, this is the output. So we can write it as V1 of S is the output. This is the input and this is the output, V1 of S by V2 of S. Now we have current transfer function. Current transfer function is represented using alpha. Alpha 1,2 of S is equal to I2 of S by I1 of S. Input, output. Next, alpha 2,1 of S, that is equal to, this is the input and this is the output. Transfer function is output by input, I1 of S by I2 of S. Next we have transfer impedance function. Transfer impedance function is Z12 of S. Z is impedance, that is V by I. This is the input function and this is second one, 2 is the output function. So V2 of S by I1 of S. Next we have Z21 of S. Z21 of S is input, output, that is V1 of S by I2 of S. We have, this is the ratio of output by transfer function means it's the ratio of output by input. Okay, next we have transfer admittance function, that we can represent it as Y12. Y12 of S is equal to, Y means admittance. Admittance is current by voltage. Therefore, this is input, this is output. Therefore, I2 of S by V1 of S. Next we have Y21 of S is equal to I1 of S by V2 of S. These are the different transfer functions: voltage transfer function, current transfer function, transfer impedance function, and transfer admittance function. Now let's see a problem. Determine the driving point impedance function of a one-port network shown in the figure. This is a one-port network and we have to find the driving point impedance function. Driving point impedance function of a one-port network is impedance means Z. Driving point impedance function Z of S is equal to V of S by I of S. So we have to find the V of S by I of S of this circuit. V of S by I of S means impedance, that is impedance of this circuit. We have to find the impedance of this circuit from looking from this side. So what is the impedance of the circuit from looking from this side? That is C parallel, R and L in series, right? So first we have to draw the transformed circuit, that is, we have 1 by CS, here we have R, here we have LS. So next we have to write 1 by CS parallel, R and LS in series. So now we can do that. R and LS in series means R plus LS, and R and LS parallel 1 by CS, so we can write it as 1 by CS into R plus LS divided by 1 by CS plus R plus LS, right? So now we can Now we can solve it. R plus Ls by Cs divided by 1 plus RCS plus LCS square by Cs. The Cs terms will get cancelled. So we can write R plus Ls divided by 1 plus RCS plus LCS square. So we can make the S term alone in both numerator and denominator. So here in the numerator we can take L common. This R by L plus S. In the denominator we can take LC as common. So we can write S square plus RC S by LC plus 1 by LC. So now we can cancel the L terms. So we have 1 by C into 1 by C into R by L plus S divided by S square plus the C term will cancel off, R by L into S plus 1 by LC. This is C. So this is the impedance transfer function of the circuit. Driving point impedance function of the circuit. Next we have a question. Find voltage transfer function of the two-port network shown in the figure. So here voltage transfer function means G12 of S and G21 of S. That is voltage transfer function. That is V2 of S by V1 of S and V1 of S by V2 of S. Okay, if we find one, the other is understood, that is reciprocal. So we have to find the relationship between V2 of S and V1 of S. V1 of S is the input voltage and V2 of S is the output voltage. So by looking into such a circuit, how can we find a relationship between V1 of S and V2 of S? By using voltage division rule. We know that V2 of S, V1 of S is getting divided between R and 1 by Cs. So V2 of S is equal to total voltage. Here total voltage is V1 of S into resistance of the same branch, that is 1 by Cs divided by sum of the resistance, that is R plus 1 by Cs. Now we have got relationship between V2 of S and V1 of S. So we can just rearrange this. V2 of S by V1 of S is equal to 1 by Cs divided by RCS plus 1 by Cs. The Cs terms will get cancelled. It is 1 by RCS plus 1. So we can make the denominator as S alone. That is, we can take RC outside, S plus 1 by RC. That is equal to 1 by RC by S plus 1 by RC. Okay. So next we'll see the rest in the next video. Thank you.